if you look at this handout here, we're doing trig. Tangent was your first trig function that we talked about, and that's what we were working on last week. And tangent was the same thing as the slope, and we said that was going to be something you have to actually write in the blank on the quiz that you take over this unit. So trigonometry means to measure triangles, basically. I might give you guys a project to do instead of a test. We may just take a quiz here, and I might give you a project to do. I'm thinking about it. So you might be thinking about something really tall that you could measure, like your house or a flagpole or a tall tree that you could have easy access to. So what I might do is we might next week work on making one of these clinometers that it talks about under that little research blank right here. Oops.
You like go outside and measure the flagpole.
Measure the. You could do that here. Why is it not sticking? Anyway, so that's probably what we're going to do instead of a test on this is do something like that. So we'll have a quiz, and then we'll probably have a project to do, and you can choose what you measure. So it might be the roof of your house or something, and I'll tell you how to do that. So if you look up here at the top, that's what that clinometer is that they're talking about there. So we may do something with that later, but you can ignore that. Up here, if you look at your paper where it says memory right here, this is SOHCAHTOA. Sine, the sine, there's the S, is opposite over hypotenuse. We've talked about tangent down here being opposite over adjacent, but we're working on the other two today, sine and cosine. So sine is S, is opposite O over hypotenuse H. That's why it's SO, S-O-H. And then CAH, C-A-H, stands for the cosine down here, is the adjacent side over the hypotenuse. So that's the A-H, and so SOHCAHTOA. And then we did tangent last week. That was TOA. Tangent is the opposite side over the adjacent side. So you've got that on your paper now. That might help, just having a written copy of it, because I don't think the book doesn't really approach it this way. I mean, it kind of talks about them, but it doesn't like give you the overall big picture view of the three different trig functions. Each one of these trig functions has something that's called its reciprocal function, where you actually flip it, but we're not going to talk about that this year. You'll talk about that in trig, okay? And if you need the memory device for SOHCAHTOA, most people can just remember SOHCAHTOA, but if you want something, it's like some old hippie caught another hippie tripping on apples. Some old hippie caught another hippie. Except the iPad's not cooperating with me here. Tripping on apples. Maybe they were fermented. I don't know. Okay. So that's the basic thing to SOHCAHTOA there. So what we're going to do now is go down to the skills area, and we're going to look at how some of these other trig functions work before we get in the middle of the questions in the book and kind of get lost in the details that they try to do there. One of the things people have trouble with is labeling the sides and figuring out the trig functions. When we do a trig function, it's always in relation to an angle. So let's look at number 1 up here. They say find x in each question, and then we're not going to do any rounding if we can help it. Okay, so if we're going to give an exact answer where we can, sometimes we'll have to round. So we'll see. Like on this first one, this is a 30-69, isn't it? So across from the 30, if I label it A, wouldn't this be a 60-degree angle up here? So across from the 60, we label that A squared to 3. And then across from the 90 degrees on the hypotenuse, we label that 2A, right? 2A. So now, I don't actually have to use trig to solve this because I just labeled it and I can tell you what. Yeah, x is going to be 6, isn't it? So I don't have to use trig to find this answer. I've got another way to do it. I could have used trig, though, so let's look at the way we could do it if we use trig. If we use trig, let me get rid of everything on here. Let me get rid of all the little things I wrote. So another way to do this same problem is to use trig. And this is why they say you don't have to know trig on your SATs. You can get by with this labeling like we just did. You could kind of get by without trig if you don't know it. It is helpful if you do. Now, what sides do I have going on here? What I usually do here is we go ahead and label our sides. Isn't this X, isn't it the opposite side? Okay. And we know this is the hypotenuse because it's across from the right angle. Usually if you label your opposite side and then your hypotenuse, it makes it easier to find the adjacent. This would be the adjacent one down here, wouldn't it?
Wouldn't it be sin?
Let's see. Yeah, I could say the sine of this angle, 30 degrees, is its opposite. I'm going to put O over H just so we remember for a minute that sine is opposite over hypotenuse. Well, the opposite side is X and the hypotenuse is 12, right? I can see that easier if I've labeled the sides. So we have different kinds of labeling we do. We label the sides with the ratios if we get a 30, 60, 90 or a 45, 90. But then we also want to label them this way. If we're going to do trig, we might want to label them the way we did hypotenuse, opposite, and adjacent.
Can you have this memory thing and put it in a proof book?
You could. I would let you put that in your proof book. You kind of need to know that one though, because when you get to, they actually give you some of it on the SAT. No, they don't. They don't give you any of it on the SAT. So sine 30 degrees.
SAT memorized. You're like, oh, they put this. No.
Well, there's some formulas at the beginning, but it's the 30, 60, 90, and the 45, 45, 90 they give you on the SAT. So that's kind of nice if you forget how to label them. You got that. So now I've got this equation. Sine 30 degrees is x over 12, right? How am I going to solve for x here? Anybody know a way to do this?
Get the x by itself.
Uh-huh.
So you do cross multiplying x over 1.
Yeah, I've got a fraction on the right. If I make the left side a fraction just by sticking it over 1, that'd be the easiest way to do this. I can cross multiply. 1 times x is x. And then 12 times sine 30 degrees. When you write that down, again, I think we talked about this last week, but just a reminder, put the number out front just so you don't accidentally leave you got the sine 30 degrees if you're using your calculator. If you leave that bracket open, then sometimes it grabs more numbers and you don't have what you thought you had there. That's hard to read, isn't it? Let me get black back up here. All right, so now, if you punch this in your calculator, it would be 12 sine 30 degrees. I happen to know that the sine of 30 degrees is a half. In trig, you have to have all this stuff memorized for your 30, 60, 90s and your 45, 45, 90s. So learning it now is a good thing. You could punch this in your calculator, but if you do, you should get 6. Is that what y'all are getting when you put it in your calculator? And didn't we find it earlier, right? We found it earlier by using 30, 60, 90s, and we knew it was 6. Remember Misha? I think, was it Misha that said it was 12 is 2 times that, so divided by 2, and we get 6. Well, here we got 6 using trig.
Wait, what does that say? X equal 125?
No, x equal, remember I was cross multiplying, so we're just keeping on working here. I said x times 1 is x, and this was 12 sine 30 degrees. I was cross multiplying this way, okay? So we're just kind of doing the working of that cross multiplication there. And it's not going to be a special triangle that maybe we just recognized from, earlier in our studies. I guess number 2 is good. Straighten. Okay. So on number 2, we got this angle here, right? Oops. Come on. Got this angle here, 36 degrees. And remember, we always do our trig functions from an angle. I can't just go pick any old side or whatever. Do I know anything about the opposite side here? GH. Nope, don't know anything. So probably not going to pick a trig function that has opposite in it. That means I'm not going to want SOH, because SOH is S-O-H, that's opposite. And I'm not going to want TOA, because TOA has opposite over adjacent. So we know we're probably going to pick cosine here. Now here's my hypotenuse, because it's across from the right angle. So let me label that. That means that this side that has the X on it has to be what? It has to be the adjacent side, doesn't it? In that little Getting Tricky with It video, which I meant to have pulled up, one point he goes, gotta be the 80J. And what he's done is they've told you how to label everything else. And if you don't know where the adjacent side is, it's the thing that's left. So if I want to find the adjacent side, because that's where the X is, and I have information on the hypotenuse, which trig function am I going to pick? I think CAH, yeah, CAH, right? CAH, whatever. So cosine of the angle, well, my angle is 36 degrees, right? When you do sine, cosine, or tangent, there's always an angle there. There's never like just the word, okay? There's always an angle after it. Cosine is 36 degrees, and we're just going to make a fraction out of the adjacent side x over the hypotenuse, and then the hypotenuse was 8. What can I do to solve for x there?
Put
Yeah,
8 over 1.
or put this over, yeah, put this over 1 and cross multiply, right? 1 times x is x, and then if I cross multiply this, it is 8 cosine 36 degrees. Now I'm going to need my calculator for that one because I don't have any special triangles that have 36 degrees in them. So what do you get when you plug that in?
Said get cross 6.4721355.
Okay. What did it say we were rounding to? I cut that part off so I can't see it.
1 decimal.
1 decimal. So if we go to 1 decimal, that'd be about what, 6.5?
Yeah.
And that's an approximate answer, right? Because we're rounding here. We can't give an exact answer on this because it's not one of those special triangles.
So just leave it as x equals.
X is about 6.5,